Good evening students, welcome to basic electrical lectures. So in this lecture we are going to start module 4, that is DC machines. So DC machines has two parts. First part is DC generator and second part is DC motors. See, in this model we already know the university question paper pattern. Each model consisting of two questions. So the questions may be like this. So fourth module now, the question will be 7th and 8th question. So like this they can ask maximum 3 sub questions, 7 ABC, 8 AB and 8 C. Like this they can ask question. Maximum sub questions they can ask 3 or more than 3 sometimes. So till now they didn't ask 4 sub questions in electrical paper, maximum 3 sub questions. See, in DC machines, most of the question papers what I referred in the previous year question papers, they have asked more weightage on theory in this particular model. Suppose if the question is 20 marks, each question carry 20 marks. So average 12 to 14 marks they asked theory and 8 to 6 to 8 marks or 8 to 6 marks maximum they asked problems. Okay, they asked problems on this particular model. Only one time they asked 14 marks problems. Okay, 14 marks problems, 6 marks theory. Okay, so they ask. See, if they ask like this, one question will be 14 marks theory, 6 marks problem. Other question will be 14 marks problem, 6 marks theory. Okay, you have a choice. You can either answer either question number 7 or question number 8. So we can take an average. We can give more importance for this particular model. We have to prepare theory in detail. Okay, derivations also there, and problems mainly based on whatever the derivations you have done it. On that only they will ask problems. But you have to think and answer the problems. Problems will be difficult in this model. Okay, there are no unique problems. Each and every problem slightly varies because there are several types of generators and several types of motors are there. So based on the particular type they are going to ask questions. We cannot predict which type motor they can ask question, which type of generator they can ask question. Lot of possibilities are there to ask problems on this particular model. So need not worry, in the upcoming lectures I will do many problems on generators and many problems on motors. So we can start module 4. So it is class number 1. So DC machines. See, in this lecture I am going to cover only introduction part. See, this introduction part is very important for basic electrical engineering laboratory. So in laboratory they will ask viva questions. In that viva questions, whatever the questions they can ask, that thing I will cover in this introduction class. Okay, let DC machines, you need not to copy anything because no question will be set on this introduction topic, but whatever I explained, that those concepts will ask in viva questions in electrical laboratory. Select DC machine is nothing but DC machine is nothing but a 2-port device. A DC machine is a 2-port device. So that you can take, this is a DC machine. So we don't know whether it may be generator or motor, whatever it may be. So it is a 2-port machine. Okay. I am considering this is port 1, and this I am considering port 2. Port 1 and port 2. There will be some input and some output will be there. So called a 2-port device. And I can assume port 1 is in electrical domain. ED means electrical domain. I am assuming port 1 is in electrical domain. And port 2, I am assuming it is in MD, mechanical domain. MD means mechanical domain. See, in a machine what happens? Energy conversion will takes place. If the energy conversion takes place from electrical domain to mechanical domain, if the energy conversion takes place from electrical domain to mechanical domain, then the machine is called motor, then the machine is called motor. Okay. If the domain quantities are DC, then the machine is called DC motor. If the domain quantities are AC, then the machine is called AC motor. In Viva they will ask, what is motor? So what you can say? An energy conversion takes place from electrical domain to mechanical domain is called motor. Otherwise, electrical energy to mechanical energy is called motor. Okay. Next. Similarly, if the energy conversion takes place from mechanical domain to electrical domain, then the machine is called generator. See, electrical domain quantities will have two types, AC quantity and DC quantity. So, mechanical energy gets converted to electrical. If the quantity is DC, then the machine is called DC generator. If the quantity is AC, then the machine is called AC generator. So, however, generally, what are electrical domain quantities? Voltage, current and power. What is power? Product of voltage and current. This is electrical power. See, current is kinetic variable or flow variable or through variable. Okay, kinetic variable, flow variable, FLOW, flow variable or through variable. And voltage is potential variable. So in electrical domain, these are the following quantities. The product of these two will give electrical power developed. Similarly, what are the mechanical domain quantities? So mechanical domain quantities are speed, torque and mechanical power developed. So speed is kinetic variable or flow variable or through variable, and torque is potential variable. The product of speed and torque, which gives mechanical power developed. So generally, see, I am going to take speed is omega. Okay, therefore torque into omega, angular speed I am going to take. Angular speed is kinetic variable, flow variable or through variable. So mechanical power developed is product of torque and angular speed. Torque into omega, that gives mechanical power developed. Voltage into current, that is electrical power developed. Okay. Now one more question they can ask. You people will tell what is motor. You are going to tell electrical energy get converted to mechanical energy. Okay. And what is generator? They will ask examiner. You are going to tell mechanical energy get converted to electrical energy. So in that process, you will ask one middle question. How it will going to convert? How electrical energy get converted to mechanical energy? How it happens? How? That is very much important. So we can discuss that. Okay. So guys, I will erase this. Pause the video. If you want, you can copy down. Actually not required. Just listen it. Okay. That is more than sufficient. Without forwarding, listen it. So what is our question now? How the energy conversion will take place? Every student will tell. What is motor means? They will tell electrical to mechanical is called motor. What is generator? Mechanical to electrical is called generator. Like that they are going to say. But they are asked how it going to convert. Electrical energy get converted to mechanical energy. How it happens. So that is important. See now, I am going to make a simple signal flow graph diagram or flow chart type. Select, you can consider this will be electrical domain. Okay, electrical domain, and this will be mechanical domain. So now we know that energy conversion takes place from electrical domain to mechanical domain is what? Very good, motor. Similarly, energy conversion from mechanical domain to electrical domain is called, very good, generator. See now how the energy conversion will take place. Between these two domains, what is required for the energy conversion? What is required? How electrical domain get converted to mechanical domain? What is required for that conversion? So what is that required? Very good, magnetic domain. Okay, so without magnet we won't predict energy conversion. So magnetic domain will be there between these two domains. Now you can define standard definitions of generator and motor. Look at here. If the energy conversion takes place from electrical domain to mechanical domain through magnetic domain. So this is the medium of energy conversion. What is the medium? Magnet is the medium for energy conversion. Remember that. Very, very important. Pakka this question they will ask in Viva. Okay. How the energy conversion rule takes place. How electrical get converted to mechanical. You should say it is due to magnetic domain. The medium for energy conversion is what? Magnet. Okay. See guys, electrical domain, the energy conversion takes place from electrical domain to mechanical domain through magnetic domain. Then the machine is called what? Motor. Then the machine is called motor. If input to the electrical domain is DC, then the machine is called DC motor. DC motor is represented by one single line. And if the domain quantities are AC, then the machine is represented by this waveform. Okay, alternating cycle. Okay, this line indicates DC and this one indicates AC. So based on the domain quantities, you may have AC motor or DC motor. What is the standard definition? If the energy conversion takes place from electrical domain to mechanical domain through magnetic domain. Okay, then only it is called motor. Similarly, if the energy conversion takes place from mechanical domain to electrical domain through magnetic domain, if the energy conversion takes place from mechanical domain to electrical domain through magnetic domain, then the machine is called generator. If the domain quantities are DC, then it is DC generator. If the domain quantities are AC, then the machine is called AC generator. So therefore, okay, therefore we can conclude that all electrical machines, okay, all electrical machines will operate on electromagnetic induction, because without magnet as a medium, you cannot predict energy conversion. Okay, got it? So some in transformer, magnetic domain will act like a flux path between the windings. Okay, so we can discuss all this in detail. So all electrical machines, static device and rotating device, static machines or rotating machines are all worked on this electromagnetic induction. However, the working principle of each and every machine slightly differ. Let's consider a transformer. In transformer, there will be not rotating part. There is no moving parts in transformer. Okay. So electrical domain is not moving, magnetic domain is not moving, mechanical domain will rotate. Okay. So mechanical movements will, some dynamic action will be there in mechanical domain. But electrical and magnetic domain, there is no rotating part. So therefore, transformer works only on these two domains. Transformer is a device, electrical device, works on electrical domain and magnetic domain. Okay. So if there is no movable part in these two domains, therefore Faraday's law of electromagnetic induction has two components. One is statically induced EMF, another one is dynamically induced EMF. So therefore, if the machine or a device works only on these two domains, then the Faraday's law of electromagnetic induction is statically induced EMF. Statically induced EMF. So in this transformer, okay, two-winding transformer works on, in statically induced EMF we have two types. What are those? Mutually induced EMF and self-induced EMF. But two-winding transformer works on the concept of mutual induction. Okay, mutual induction or mutually induced EMF. Similarly, auto transformer, in laboratory we are using this. Auto transformer works on self-induced EMF. See, auto transformer is also called one winding transformer. In short form, WDG is winding. So one winding transformer, it works on self-induction. So it statically we have two types, mutual induced EMF and self-induced EMF. So what do you mean by mutual induction? Whatever the flux produced in one coil will also links with the neighboring coil. That is called mutual induction. So therefore, transformer is a static device. In static device, what are the domains present? Only electrical and magnetic domain will present. Okay. What about remaining machines? Transformers, two winding and auto transformer is over. What are other machines? You might have listened or you might have observed in your lifetime. Okay, generators. See now, generators, DC generator, okay, AC generator, DC motor, AC motor, induction motor, okay, synchronous generator, or alternator, or special machines, okay. All these are example of rotating machines, okay. In all these rotating machines, all these three domains are included. All these machines include electrical domain, magnetic domain and mechanical domain, okay. So therefore, all rotating machines basically works on dynamically induced EMF. So if all these domains are included, then the fundamental electromagnetic induction working principle will be dynamically induced EMF. All this machine basically works on dynamically induced EMF. But the working principle of each and every machine slightly varies. But basically dynamically induced EMF. We can see about generator. So in generator, the EMF will be induced due to relative motion between conductor and flux. That is called dynamically induced EMF. Something will rotate. Whenever the conductor cut the flux, an EMF will be induced. So mechanical action takes place here. This conductor cut this flux, EMF will be induced. Then that is called what? Generator. Okay. So next, look at here. So in case of generator, the direction of induced EMF is determined by Fleming's right hand rule. The direction of induced EMF is determined by Fleming's right hand rule in case of generator. Similarly, in case of motor, what do you mean by motor? Electrical to mechanical. So whenever a current carrying conductor placed in a magnetic field, it experiences a mechanical force due to interaction of the two fluxes. What are those two fluxes? Main flux and current carrying conductor flux. When both fluxes are interacting together, it produces a mechanical force. So the direction of that force is determined by Fleming's left hand rule. So in motor also generating action takes place. So that's why the basic principle is dynamically induced EMF. However, the direction of the whatever the back EMF, whatever the generating action takes place in the motor, that is according to Lenz's law. See, Lenz's law and all other laws are a part of electromagnetic induction. So fundamental principle of all the rotating machine is what? Dynamically induced EMF, but slightly different. Keep that in mind. Okay. So in case of motor, the direction of force is determined by Fleming's left hand rule. Okay. So similarly, in case of induction motor, it is having both the transformer action and the motoring action. Induction is what? Mutual induction or self-induction, like that. Okay. Induction is static part. Okay. Motor means motoring action. Okay, it is having both statically concept as well as dynamically concept, induction motors, and synchronous motors also. Synchronous motors and induction motors will have both static concepts as well as dynamically induced EMF concepts. But induction motor works on the concept of rotating magnetic field. Induction motor works on the concept of rotating magnetic field. And synchronous generator is nothing but AC generator. Both are same. And alternator also same. Next, coming to synchronous motor. Synchronous motor works on the principle of magnetic interlocking. Okay. Synchronous motor works on the principle of magnetic interlocking. Okay, got it? And all special machines. Special machines nothing but small machines used for desired applications. For example, stepper motors, repulsion motor, brushless DC motors, all such type of motors we are using in robotics and car door systems, movements, and car glass cleaning. Some motor will be there to clean the glass during when rain comes. Okay, all such type of machines are called special machines. All special machines are rotating machines, maybe static machines. Okay, so guys, understood? This completes the introduction about the DC machines. Understood now why all the machines works on the principle of electromagnetic induction? So this is the reason for that. Okay, so which device works only on this electrical and magnetic domain? Transformer. Okay, in transformer, what is the transformer? There is no movable part. So transformer, in Viva they will ask, at what speed the transformer runs? What you should say? It is a static device. Transformer will not rotate. Okay, got it? Fine. So guys, have a nice day. Take care. So, ಮತ್ತೆ next video ಅಲ್ಲಿ ಸಿಗೋಣ. In the next video onwards, I will do syllabus topics. So next topic will be working principle of DC generator. Okay, and later I will upload as per the syllabus. Okay, take care. Bye bye. Have a nice day. ಸೊ ನನ್ನ ಚಾನಲ್ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಶೇರ್ ಮಾಡಿ, ಸಾಧ್ಯವಾದಷ್ಟು ನಿಮ್ಮ ಸ್ನೇಹಿತರಿಗೆಲ್ಲ ಕಳಿಸಿ ವಿಡಿಯೋಸ್ನ. ಸೊ ಲೆಟ್ ದೆಮ್ ವಾಚ್ ಅಂಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇನ್ ಎ ಬೆಟರ್ ವೇ. ಓಕೆ, ಎನಿ ಕನ್ಸ್ಟ್ರಕ್ಟಿವ್ ಸಜೆಷನ್ಸ್ ಆರ್ ವೆಲ್ಕಮ್ ಟು ಇಂಪ್ರೂವ್ ದಿ ಕ್ವಾಲಿಟಿ ಆಫ್ ಟೀಚಿಂಗ್. ಸೊ ಥ್ಯಾಂಕ್ ಯುವರ್ ಸಪೋರ್ಟ್. ಇದೇ ತರ ಸಪೋರ್ಟ್ ಮಾಡ್ತೀರಿ. ಸೊ ವಿಡಿಯೋಸ್ನ ರೆಗ್ಯುಲರ್ ಆಗಿ ಅಪ್ಲೋಡ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಬಾಯ್ ಬಾಯ್, ಟೇಕ್ ಕೇರ್.